Good morning, good afternoon, or good evening from wherever you're joining us from today in the world. Welcome to a Microsoft Reactor Sydney live stream event. Today, I'm excited to welcome back Jessie Luden, who is joining me today to discuss authorizing custom Azure policy definitions. Authoring, sorry. So firstly, a bit of background on Jessie for whoever is joining us today. Jessie is based in Sydney, Australia, and a principal consultant at Lab3 and a Microsoft MVP specializing in Azure. He has worked with many enterprise customers over the years to design and deliver infrastructure guardrails via Azure policy, and has publicly presented and written on the topic several times. So we'll be speaking for about 45 minutes with questions throughout and towards the end. However, do ask your questions in the comment section as they come up, and we'll try and answer as many as possible. Additional links at the end will be shared in the PowerPoint slide with a QR code, so you can check that out as you go on the live stream or on demand if you're watching later on. And we'll also share with you a link to our survey if you have time to fill that out. That would be greatly appreciated. And if you'd like to reference back today's session, you can do so on the Microsoft Reactor YouTube channel, and the link for that will be in the comment section a bit later on. But for now, I will hand the floor over to Jessie to begin. So thanks so much, Jessie, and over to you.
Lovely. Thank you, Sarah. Hi, everyone. So that was a good introduction. I don't need to talk anymore about myself. I do have another slide just here, quick introduction again. So my background is pretty much infrastructure and sysadmin. Was introduced to Azure around 2018 when I made the jump from primarily working on on-premises environments in Citrix and VMware. So nowadays it's very much everything in the cloud, everything as code. And I've kind of specialized on Azure policy because I feel like there's a lot of value there, particularly for large enterprise who are really ramping up their cloud adoption and needing to apply those guardrails to their infrastructure as it scales and as it grows. There's a really large gap there in terms of controls. So if you're joining us today, you may already be familiar with Azure policy. I hope you are. There's a certain amount of assumed knowledge, I think, because this is a fairly technical session. So the abstract for today, I'm going to go through a quick refresher on Azure policy. So if you are new to Azure policy, don't worry. I'll cover a lot of things that are key to understanding how we use Azure policy to apply governance and how it works behind the scenes. I'm then going to look at authoring examples and some gotchas that I found along the way, which may help you in your own authoring journey. And then finally, we'll look at some tips and tricks. So things that have helped me to streamline the authoring process and make sure that I have an accurate and workable policy, which can then be pushed to production. So without further ado, this is a slide I've used quite often in the past, just to give like a broad overview of the Azure policy ecosystem. And it is up to date. So those numbers that you see on the right here, these are the up-to-date numbers as of today. So there's over 900 generally available policy definitions. Last time I checked earlier in the year, there's probably 700. So as Microsoft add more definitions and make them generally available, this number is going to increment higher. But that's already quite a large number in my view, across 71 categories. So a category could be anything from SQL, storage, compute. This alias number is quite incredible, 54,000 actually. 6 months ago, I think this was 45,000. So aliases are, if you don't know, they are the key mechanism that Azure policy uses to actually do compliance checks and apply governance to the resources that are being provisioned and changed in Azure. Namespaces here are things like Microsoft Storage, Microsoft Networking. So these are all the supported namespaces, supported resource types as well. And the largest number of aliases that are currently available today are attributed to network aliases. So that's quite incredible. I'll show you as well this spreadsheet I did just earlier today just to get that number. So this is an export out of AZ advertiser, which has all the aliases available. You can see Microsoft.network here is leading the charge in terms of the number of supported aliases that are in Azure policy, and most of those are with application gateways. But that's quite incredible, right? So if you're looking to use Azure policy, you may want to visit some of these sites. You probably know them already. So Microsoft Docs, I go there pretty much every time I'm doing something with Azure policy, just to refresh, my knowledge of what the latest guidance is from Microsoft, and things are always changing, of course. Officially, there's a few code repositories. So there's the community policy, which has a number of definitions that have been accepted and synced over by Microsoft from the community. The Azure policy repo, of course, is a good base for your knowledge and for checking if there's any issues with particular providers or particular aliases. It's kind of like a knowledge base in a way as well. Tooling, you've got different tools you can use to manage Azure policy and deploy Azure policy as well. There's a few community sites here I've highlighted. So yeah, that's a good overview, I think. Resource aliases. So this is a nice slide that we'll go through now. So aliases, as I mentioned, they're a key mechanism for policy. When there's a request coming through in Azure from anywhere, it could be from any consumer or user of Azure, that request will have an API version. In this example, I've got an API request coming in for a disk resource, right? And you can see the SKU. I've just highlighted a few properties here from the request. So what happens is that request gets sent to Azure. Policy is going to do a check. If you have a policy that's looking for that particular resource type and resource property, so it's going up here. So in our Azure policy definition, we're looking at a field called compute disk SKU name. So this is actually an alias. So here we're actually doing a equals check. So we're looking for a particular value. So because that alias matches what we're actually sending through in the request, the actual resource gets evaluated. So it's in the evaluation scope in a way. So the way that policy does that is it goes and checks the particular resource alias definition, which it has in its own lookup. So here it's looking at this resource definition, matching that resource type and name, and it gets the path of the actual resource property there, which is SKU.name, and it matches the API version that we were sending through as well. So there's lots of different definitions, lots of different aliases. This is just to show you how it works behind the scenes, so that when you are authoring custom definitions and troubleshooting, if you're not seeing the right results or the right data coming through, you may want to look at and to dig around behind the scenes as to whether your alias maps to a certain property and what the path of that is. So this data here that I'm showing in this box is actually an export that you can get from Azure just by querying it through Microsoft PowerShell or Azure CLI. You can get this information. So SKU.name here. So in your request, SKU name and then premium LRS. So that matches with our policy definition, which means the resources in the scope of the compliance check. And then we can apply policy effects. So there's different policy effects, audit or deny. So in this case, we might be denying that resource if it matches premium LRS, because we don't want, particular disks to be created with premium LRS because of cost considerations, for example. So that's really just how it works end to end in terms of the evaluation using resource aliases. Effects-wise, there's different effects and they get evaluated at different times. So this slide is really just to illustrate that these effects here at the top, disabled, modify, append, deny, audit, these are evaluated during the initial put and get request as it comes into Azure. Why that's important to understand is because when you're creating custom definitions and you're trying to use a certain effect, if you're not getting the desired result of your compliance check, it may be because the put and get request, and the property that you're actually trying to check against in your compliance is not actually like that data is not actually in the initial put and get request. So you can't, for instance, if you have a property that's only available in a subsequent put and get request, because there might be multiple that come through into Azure, you might have to use audit if not effect, which is evaluated after the initial request. So that would be this one here. So something to keep in mind. Patch requests as well will come through as well. So there's kind of equivalency there. And then where you have, you're trying to do a deploy if not exists effect instead of a modify, that's typically a 10-minute delay. So by default, after the request comes through and your policy's got a deploy if not exists effect, there is a standard default 10-minute delay before your deploy if not exists effect will actually run and implement the change on the resource. You can cut that down to under 10 minutes. So whenever the resource deployment is successful or failed, depending on what you desire, using a property called evaluation delay, which I've highlighted here. So that's a new property, new as in the last 6 months or so. So without that, you'd have to wait 10 minutes every time something is changed or created that's in scope of your deploy if not exist policy. Yeah, so this is an overview of the effects and when they get evaluated. Hopefully that's a good primer. Now parameters are really key for custom definitions as well in terms of that reusability. So I wanted to just show you this slide here, which is illustrating that parameters, they come from the definitions, right? So we've got built-in definitions and custom definitions. Built-in definitions are managed by Microsoft. So Microsoft handle everything for them. In the backend, they create, delete, modify. And we don't have any control over the definitions in them. We can consume the definition and create them in initiatives or assign them out by themselves directly. But for parameters, we can't change the parameters in the definition. We can only pass in values for the parameters. So there's less control with the built-in definitions in terms of parameters, but custom definitions that we'll cover today, we have full control. So we can do as much as we want with those custom parameters in the custom definitions as well. And then we might have a mix of built-in definitions and custom definitions in a single initiative. So they're linked here. You have full control over custom initiative, of course. And then when we go and assign that out, the parameter value can be updated as well. So you can update parameter values in the initiative and update parameter values in the assignments. And this is where it kind of gets a little bit tricky, because if you're doing updates on both, like, you're updating the same parameter value on the initiative and the assignment, it's a bit hard to know what the end state is. Really, the assignment is going to override the initiative value. So what I recommend is just try and do the updates at the assignment level only and just leave the initiative parameter values, whatever the default settings are, unless you don't want to do assignment parameter value updates, if that makes sense. So it kind of, if the reason I want to show you this as well is if you get parameters wrong, so if you don't optimize your parameters at the definition level, it can have a flow-on effect. For the initiatives, for the assignments, and then when you go and assign that out to different environments, there could be some some drawback in terms of checking compliance and remediating, and it gets really messy. But this is really just how it works and links together all the way from the left, which is definition, to initiative and assignments. I think I just saw a question as well about a GitHub link. So yeah, I'll give some links to GitHub where you can see examples of custom definitions as well. Just give me a few minutes as I walk through these slides. All right, so we've covered aliases, we've covered the ecosystem policy, effects, and parameters. So let's talk a bit about the authoring process. So typically when you're authoring a custom policy, you'll have an idea, you'll have a need. That's really about, where am I starting? And this is about establishing the business case and requirements, right? So I have an example for this that I can talk through as well. But basically, you want to start from a case of what's the actual need, and what do I need this policy to do? So if you have that in mind, that's a good starting point, because then where you might need to change things later on, or you want to get your policy as refined as possible and focused as possible on meeting that business case. If you can get a bit wish-washy, if you have a few ideas but you're not sure which one is what's required, that's where you may just waste quite a fair bit of time with a number of different policies that are not really meeting your requirements. So you establish that business case and requirement first. I have an example I can show you about data masking for SQL databases. So after that, you want to check for any existing built-in policies. Why that's good to do is because if you just run in and head first just start creating a custom policy, you may be wasting a lot of time, because you don't have a starting point, unless you've done this many times before and you have a very good idea of what you need to do. But if you can check the built-in policies and see if there's like something similar to that resource type that you are looking to apply governance to, you can get a lot of good value just by looking at what's existing already. You might not use that word for word in terms of the custom definition, but you can at least get some ideas as to how Microsoft were doing the compliance check or the deployment or modification of the resource, and make sure it's directly related to the resource type that you're working on as well, because that makes a big difference. So after that, you then create a baseline custom policy definition. So of course you can copy an existing built-in one to start from scratch. But the baseline, what I mean by baseline is bare bones. So nothing in terms of parameters, just hard code everything, statically hard code everything. Just make it as, minimum viable product as possible, MVP, so that you are not wasting time with troubleshooting or diagnosing things that don't really matter at this stage. So just make it as, as simple as possible, just so you can do the compliance check or remediation if that's what you want to do. Start there first. And then the next step after that, I'm going to test and validate. And test and validate has kind of two steps, so I've broken it up. First, you want to do the compliance evaluation. So compliance evaluation will be, you have a non-compliant resource that you've deployed in scope of your new custom policy definition assignment. And you need to verify that the non-compliant resource is getting picked up by your new custom policy definition. And if it's not, then you need to go back to your definition and tweak it. Maybe it's the alias, maybe it's the condition or the expression or the value of what you're trying to check is not right. So there's that. You want to tackle that first. If that works, then you move on to the next one, because remediation is kind of a different ballgame, right? Remediation kind of encompasses role assignments and permissions, and sometimes ARM templates if you're doing a deploy of an exist effect. So there's a few more things you can get caught up on with remediation if that's what you're looking to do. So that's why I recommend splitting up these two, step 4 and step 5, split those into separate tasks, and definitely nail step 4 first, that you actually have a non-compliant resource getting picked up by your custom definition. So let's say we get remediation working. That's all great. We've tested that in our test and dev environment. After that, we want to do a bit of parameterizing. So, the effect parameter is a very common one because the effect can be changed quite often. It might be a deny or a modify or a disable. So that's something you want to at least have in your custom definition. You might have other parameters for values that should change as well, like different names for resources or tag key and value changes that may be applicable to your custom definition as well. And the reason you do this is so you can maximize reusability of your definition. So you can use that in many different places, not just for a specific use case, but you don't have to like have the same definition duplicated many times just with different values if you're parameterizing it. So after all that, you do final validation, just make sure it works. Nothing has broken it in this parameterization step. Importantly, that's also why we split it up, because I have broken things before in the past. Final validation and then ship it. So, great job. You've gone through these steps. It's worked in a number of different, cases. Maybe not every case you've been able to test because of, time constraints or budget. But this is really like, the baseline that should be end to end. Each point of these should be covered before it actually gets into production, really. So let me show you an example. So I mentioned data masking. I had a use case, a business case, a requirement recently for a client to look at data masking for their SQL databases in Azure. So the first thing I did is I actually went to Microsoft Docs, looked at data masking in terms of what it does, different properties, different different changes it can do, best practices, common use cases. So I've kind of early validated that data masking is a thing with SQL in Azure. So it is possible to enable. That's my kind of first validation there as well, once I knew what I wanted. And secondly, what I did is I actually looked at the existing policies. So up here, I've got the community website. This is a free website from Julian Hayward, is an employee at Microsoft. So this is AZ Advertiser. So what I did is I'm in the policy blade of AZ Advertiser. So this shows me all the built-in policies and community policies in its own database. So I can easily search here. So if I search for a task, it's not going to find anything. Just to show you that it does find things if I remove mask. I'll just search for data. So you can use this trick. Basically, if you're looking for existing policies, you can go through the portal as well, of course. So if I search for data masking, so these are the custom definitions I deployed, which I'll showcase in a second. But you can search through the portal. The problem with that is it doesn't show you policies that are from the community or other sources other than that are in Microsoft as well. So that's why I use this website, because it also has other sources of policies that are out there and trusted as well. So there's nothing for data masking. Okay, so I verified there's nothing existing at the moment for data masking, but I knew that what I wanted to do next was look at aliases as well. So the same site, I can look at aliases. You can also query aliases through PowerShell, Azure CLI, etc. So this is a alias single line view. So if I search in here for I can try and search because it's loading in the background. I'll just wait for it. So this is the page that has over 50,000 aliases running on a database in Azure. So it does get a little bit needy on resources sometimes. But what I did anyways is I searched for the alias for data masking. And I did find some aliases that were available. Still not responding. I might try and open a new page. see how this goes. Close the old one. Possibly I'll hit the same bottleneck, which would be awesome. Yeah, so okay, while we're waiting for that, back to the question about a GitHub link. So if you want to check out some GitHub links, there is awesome Azure policy. Just search for that in GitHub. It's basically a bookmark repository for a lot of different links relating to Azure. So in here, you have a lot of GitHub links in the community repository section relating to Azure policy. So you've got policy samples, policy testing, custom policies that everyone else has done as well. And if you scroll to the top, you can also see some official repositories for Azure policy as well. So there's the Azure policy repo. This one here I mentioned is a good knowledge base in terms of patterns, samples, issues with different providers and such. So yeah, if you check that out. Oh, the page is not working. Oh, it's working now. Let me refresh it. There's maybe too many people are hitting this right. Yeah, that's fine. So what I did as well as a backup, I actually exported every single alias from that website earlier. So I can use this to just show you what I would do in terms of looking for an alias. And then why I want to look for an alias, because if no alias exists for data masking, I'm not going to bother with a policy. It's not possible. So there needs to be an alias that's available, first and foremost. So I need to be able to do a check on an alias. So that way I can actually just verify. I can create a policy for it. All right. So alias, Excel filtering. This is a very large file. Data mask. Okay. So there's data masking. Cool. So there's data masking aliases for API management. Sorry, I'll zoom in a bit. That's really hard to see. So there's data based on my filtering of aliases in Azure. There's masking aliases for API management, SQL Server, and Microsoft Synapse workspaces, because they have SQL pools in them as well. So the ones I'm interested in are the SQL Server aliases. And I picked out, so when I was looking at this before going through it, I picked out two particular aliases that were really interesting in terms of my use case, because my business case is I want to verify that data masking is enabled on a SQL Server database, right? And there's two aliases here that I've highlighted. One is for the data masking state. Actually, they're both for data masking state, but one's for default. It's got default. That's really the only difference. So what I did is I took both of those, and you can see actually the modifiable attribute of all these aliases are false. If you don't know, if an alias is modifiable, it means that during the initial API request, put and get request that comes through to Azure, if it is modifiable, that means you can do a modify or an append on that alias during that initial request. If it's not modifiable, you can do a change using an ARM template, using a deploy if not exists effect. So all these are non-modifiable, which means they're false, which means if I wanted to enable data masking through an ARM template, I could do that, but I wouldn't be able to use a modify or append policy effect, if that makes sense. Cool. So now I verified that data masking state is a thing that I can do a check on, relates to my business case. So I'm going to go back and just show you what I started with is this custom definition here. So in Azure, in the Azure portal, if you create a custom definition, it gives you kind of like boilerplate code. So it gives you a good baseline. Of course, you can do this in Visual Studio Code as well in your own, in your own local repository if you might have one. I just did one in the Azure portal. So here's my custom definition. It's got a parameter for effect. The rule is really simple. I'll see if I can zoom in a bit more. The rule is looking at the alias for databases. So I want to include that as my database, catch, basically. If the request coming into Azure is a SQL Server database, then catch that in this policy definition. So that's relating to this field and type. Field type equals SQL Server database. So this is an all of statement, which means every single object here that I have in this array needs to be equal to true, basically, for that equation to be met. So I've got SQL Server databases needs to be true, and the name of the database not equals to master, because I don't want to check if data masking is enabled on the master database. It's only for the other databases that are in the SQL Server. By the way, where I got to this in terms of the code that goes into this, I actually checked a few other policies that were doing things on SQL Server databases. So I actually, got the idea of what the possible if statement could be. And that's why I was talking about before with the authoring process. You want to do a check on other resource types that are the same as what you are trying to do a compliance check on for your custom definition, so that you can see how did they do in that one. You can get ideas from that and just not copy everything in terms of word for word into your new definition, but at least take some elements of it that you think will work, right? So I took an element there for the SQL Server database type, and the database name not being master. I think that's good. And now the effect here in the then statement. So the if and then the details of the type equals the type of resource that I am checking against, right? And the name of the resource default. And now existence condition is going to be, okay, this is what needs to be true for my policy to mark this resource as compliant, right? So we need to include this when we're doing a type of compliance check when the effect type is an audit if not exists. So if you remember when I was talking about effects and when they get evaluated, this particular effect type is an audit if not exists. Could be a deploy if not exists as well, like I mentioned. So it wouldn't be an audit or a modify or anything like that, because the property is actually sent, like it's actually checked in a subsequent ARM request. So it wouldn't be the initial request that comes through that has the SQL database masking state in that request. So it means we need to use, an audit if not exists. And then we need to include an existence condition in this area of the policy definition. One tip I will give as well is just pausing that. So if I go to Microsoft Docs for the Azure policy definition structure, they actually have a link there to the definition schema. So if I go to that, it's totally unreadable right now. But if I take that into Visual Studio Code, and I need to select the text and Control Shift P and then format to auto lint. So this is the schema that is for policy definition. This is what's checked basically when you create a custom definition. It checks this schema against your custom definition. So here, if you're not sure on different properties or where the placement of different properties need to go, and you don't have an example that you've searched for, or you can't find something in GitHub or online, you can look at this schema to basically validate, okay, what are the possible effects, right? So it's saying here there's different effects. There's append, audit if not exist, deny, etc. How about the different details for each effect? Well, here you've got append details, so you can see the type is an array, properties required, field and value is required. So you can kind of interpret this if you get stuck. I mean, really stuck. You probably wouldn't go to this schema first in terms of creating a custom policy, but if you do get stuck, it is there for you. Now, back to my custom policy. So this one I'm showing you, it's a V01. So I actually know it doesn't work, and I'll show you why. So here I started with that alias I found. So I had two of them, right? And I'm checking a value on that alias. Now I got that value actually by looking at the ARM template specs, particular resource definition. So I just searched for data masking policies. Looking at the ARM template specs, I can see, okay, here's some different values. So resource name, you can maybe remember I've got name there. So that value there is default. It doesn't look like there are any other values. And then data masking state is quite important. That's what I want to check against. So you can see you've got different values here, disabled, enabled, and these are required values as well. So back to my custom definition, I've tried to, include that in my custom definition, and then I've assigned that out to my resource. So in my test environment, created a new resource group just for this demo, basically. But yeah, this is actually a real case that I went through in terms of and so I created a SQL server, 2 databases there. None of them have data masking enabled, which I'll prove. So if I look at data masking, there's no mask created on DB2. DB1 also has no mask enabled, right? So I had my resources created for testing this custom definition, and I had my policies as well. So I showed you V1. So V1 is here. So DB1, I can see 2 non-compliant resources, both for both databases. And the reason I have 2 definitions assigned, both to that resource group scope, is just so I can make changes, in one definition without affecting the other one, and I can do things a little bit more, in parallel. Because when you're testing policies, there's a lot of waiting. If you've ever tested a custom policy, you'll know, okay, I need to wait for the compliance scan to run, and I need to, trigger another scan and maybe wait 30 minutes. Depending on how many resources you're trying to check and how big the environment is, it can take a while. So a tip I can give you as well is when you're doing custom authoring, if you need to make multiple changes to the definition, try and duplicate that definition without changing the original one. So just create a new definition based on the previous one, make your change in that new definition, assign it to the same scope. And particularly when you're just checking compliance, this is a good way to just streamline your authoring process. So I might make a change in V01 here, but not make a change in the other definition, and then I'll test that out. And then also, I usually in the portal, if I'm doing stuff in the portal, also trigger an Azure Policy State trigger scan here. So this is useful in your current subscription. You can trigger a state scan to actually just manually kick off that compliance check. So there should be less waiting. when you trigger that. So I'll do a no wait there. Also, when you're doing custom definition testing, if you set the scope of that assignment to maybe a resource group where your policy resources are, that should actually speed up the compliance check as well, rather than setting it to, say, subscription scope or management group scope, because there's fewer resources to, the scope is smaller, so there's fewer resources to check as well. So that's something to be aware of. Let me check in this V01 definition as well. Default enabled. So that's pretty much the outcome I was looking for, really. So when I created these resources, I wasn't sure if it was just going to work. But when I saw that we had these non-compliant resources being picked up by the policy, and I can see in the compliance reason details blade here, current value, target value. So that's as expected. But if you run into issues here and you're not seeing the right resources coming up in the compliance results of your policy definition, you kind of need to go back to the drawing board a bit, which is what I explained before, where you go and tweak the definition, and then if you can at least get the non-compliant resources showing here and it looks good in terms of what you expect, then you move on to remediation if that's part of the plan, right? So back to your business case, do you need to remediate, or do you need to just do an audit or deny? So that's what I would suggest in terms of authoring and testing as well. So what I can do as well with this definition, now that we've actually tested the compliance evaluation, what I could do as well is I could even change the parameter effect, the parameter for effect to a deploy if not exists. And then if I wanted to uplift this definition to a deploy if not exists remediation, so that data masking is enabled or some sort of data masking policy is created, I would then go back to my ARM template page. I'd then look at some examples of ARM templates where data masking is configured, and look at it, how they're doing that. I'd take that ARM template into my custom definition, and then do some testing there. But I'd probably make a new definition, so not modify this one that I know works in terms of the auditing. So I'm not having to create more work for myself down the track if I backtrack back to an auditing state. One thing I might do as well is add a tag evaluation here. So if you look at some definitions that are in Azure, this is one way you can actually select different resources to be scoped. Let's see, based on tag. Configure backup. Okay, so this is a good one. So here's a built-in definition for configuring virtual machine backups with a given. So virtual machines with a given tag can be configured to recovery service vault. So if you look at this parameter, you've got inclusion tag name here. Default value is just an empty string, and the tag value is an array. So you can include multiple tag values. It's an array type against a single tag name. But this is a good way to include a tag evaluation for a certain resource that you want to apply a compliance check to. So the way that they did this is here in the definition, if I just search for a tag name. So this is how they do it you can see here if any of these objects here equal to true, then the policy will mark the resource as included in scope. So here you can see it's using the tag alias, which is a concat. It's checking the tag name, and then it's looking at the parameter for tag values. So it's using an in expression there, which means it will check every single value that's in that parameter. So that's one way to do it. There is to do it too, but that's very common if you look at different tag custom definitions. Another thing they can do is check on the empty parameters. So they're looking at tag value. If it's empty true, then it wants to also include the resource in the evaluation, and same with the tag name. So there's many ways to approach this problem in terms of applying different conditions and expressions. If you weren't, my advice is if you weren't sure as to which one you should take in terms of copying this into your own use case, just take one of them first. So maybe take that top one, because if you take everything and it doesn't work, according to what you expect and what you need, it's getting complex very fast. So if you just simplify it to the bare bones, take one of the actual properties or objects here into your own custom definition, that's probably going to help you down the track if you need to do any troubleshooting. This is also, if you know Azure policy, you'll know anything that deals with virtual machines. The evaluation if statement is very, very large, because there's a lot of different types of virtual machines. So there's different SKUs, and the Microsoft way is to actually cater for a lot of different use cases in terms of what gets provisioned for all these different types of virtual machines. So in terms of what you would do for your own custom policy, if you needed to create a custom policy that dealt with a lot of use cases, you either go two ways. You create a different definition for every single use case, or you create one definition, like a mega definition like this, but you include scoping in your if statement for each of those use cases. So I'm not sure if there's pros and cons that would weigh heavily on one or the other, but there's those two approaches that I would suggest. Either a mega definition with lots of use cases in the if statement, or multiple definitions but very trained to one or two use cases there. Yeah, that's a mega one. So that's how you can include tags in your evaluation as well, not just the resource type, because tags are really good metadata. They should be standard in your environment in terms of applying tags, mandatory tags to different resources like environment, owner, application name, that kind of thing. So yeah, if you ever get stuck with you need to constrain a policy to a certain use case or something, tags are a good one to include as well. So yes, that's really the back to okay. AZ advertiser finally loaded. Let's see if search will work as I was planning to do before. Data mask. There we go. So these are all the data masking aliases. It's 4 pages, but if I increase the number of records, it'll show more results on the one screen. So these are all the SQL ones. So same information as I was showing you in my spreadsheet here, as I exported it. Maybe you want to export it as well, so you have an offline copy. Let me show you an example of a modifiable alias, which can be modified in a modify effect. So if I go to Azure, you could go to definitions. And when this loads, if I search for modify, so let's look at Azure Event Grid topics. So these are some built-in policies that modify the resource in that initial put and get request. And I'll show you the alias that it uses as well to do that, and that the modifiable value is true. So if I go to this one on configuring event grid topics to disable network access, the parameter for effect, which is very common, is modifier. That's by default, or it's disabled, right? This could also be an audit if they added audit in the allowed values as well, but they didn't, and they is Microsoft. So the resource type event grid topics, this is the alias for public network access, and they're looking if it's disabled. And if I scroll down, so here in the then section of the custom definition, they have the alias here under field and value. So this is what they are in a modify effect. When you're doing that in your custom definition, you have a number of operations that you can apply. So you can do an add or replace, or I think replaces might be the other one. So here they're doing add or replace, and the value here is disabled, and they're changing this particular property through this alias called public network access. So if I copy this alias into Visit Advertiser and search for that, see how this is on the fly as I'm searching. That was very quick. All right, so that's the alias from the built-in definition, and you can see the modifiable value is true. And that's why they can use the modify effect, because it's able to be changed in that initial request that comes through into Azure. So I generally think, modifiable aliases make it easier. There's a lot, I think there's some backend work that Microsoft and the different provider teams have to do to make an alias supported in terms of modifiable being true. But I generally think if it is modifiable, it's easier to do compliance, control, governance, and automation for the property and for the resource, because you don't have to have an ARM template in your policy definition. You can just have this very streamlined, minimal kind of operational condition field value. It's very, very simple. If you have to do a deploy if not exists effect, it gets a bit more involved. You have to include an ARM template, and there's different parameter values and properties, and the schema is different as well. You have to account for as well. To take that into account, depending on the effect you want to go for, you can kind of estimate how long something might take in terms of the authoring process and what may be involved as well. Modify is generally easier to author than deploy if not exists. Yep. So let me go back. All right. So hopefully that was a good kind of demo on a recent custom policy that I was working on, and the thought process as well in terms of how I went about it from start to finish. Establishing that business case and requirements for checking that data masking was enabled or not, and creating that custom baseline, and then validating. In this case, I wasn't looking to remediate, but if I did, that would be more time taken and more testing in terms of does that work, and that's important to separate from your compliance evaluation as well. Parameterizing, I could certainly improve on parameterizing, but I haven't rolled it out to production yet, so I can still work on that in the background. So hopefully that helps you in terms of 8 steps. And yeah, if there's any questions about that, do up. That was the pretty much last slide. I think we made it just under an hour, but thanks for watching.
Thanks, Jessie, and thank you to everyone for watching. As Jessie has just mentioned, we do have the QR code on the screen now with all of the links provided from today's demo and presentation, and all other links to the Reactor Meetup page and our Reactor website, YouTube channel, and survey are also all in the chat for you now. You can contact Jessie if you have any further questions about the presentation. His contact details are there on the screen as well. And yeah, I think we'll leave it there for today. So thank you so much, Jessie, again for presenting with us. And thank you to everyone for tuning in. Have a good rest of your afternoon, evening, or morning. We'll see you next time for another Microsoft Reactor Sydney live stream event. Thanks, Jessie.
Thank you.